I think good evening, everyone. So welcome for today's webinar. So today we will be introducing an micro ID's interlock system. Okay, so today's topic will be interlock. Let me start with the slideshow. Open up with the slideshow. Okay, if you all not able to hear me, and if you're not able to hear anything, you just inform me. Okay, if there's any questions, you can raise it up, or you can voice it out as well. Okay, so with that being said, let me start for today's section. MicroID is a door access control company. Since we are dealing with doors, with some added logic, the doors will become interlocking system. Therefore, today we are going to discuss on micro ID interlocking system using our own smart IO board, where a smart board does a lot just for an IO. Smart IO board, previously known as IO board, but this board is able to do so much that we had to add the word smart to it. With 4 inputs and 5 relay outputs, we are able to do multiple things or functions using this input and outputs. So without wasting any time, let's look into the functions, the list of functions that we have. Remember, we don't just sell hardwares. We sell solutions in the form of functions. So the basic list where we have 2-door interlocks, 4-door interlocks, multi-door interlocks, basic IO, panic button, timer, time schedule sounder, and the board is able to accept wireless, peer-to-peer, and RF. The board is also able to communicate to each other in peer-to-peer. So if you want to know more about the peer-to-peer and wireless, you can go look into our previous videos on smart converters. It will explain you in details on that. So this peer-to-peer is micro ID's standard of communication, wireless communications. Okay, but today's topic, we will only emphasize on only a certain functions of it. So today's discussions, we are only going to emphasize on the interlocking system. So the interlocking systems we have is the 2-door, 4-door interlocks and multi-door interlocks. At the same time, today we will be introducing to you the first time our latest interlocking board as well. So that one will cover that in our end of the slide, and what is the capability of that interlocking also we will explain to you. Introduction to interlock. Sit back guys and enjoy watching the following video. Let's see how to enter into a clean room. First, you enter the changing room. You change into a clean clothes. Then you enter the air shower room. Then at last only that you can able to enter into the clean room. Let's see how to enter into a clean room. Okay, this is another clean room. As you can see, they're pressing the push button to releasing the door to the air shower, and they enter the air shower. Then once it's done, then only they open the exit door itself. What is door interlock system? From the video we can. So guys, Just now we showed the two videos which explains about how a clean room works. Okay, so basically interlocks are used in those areas. Okay, so we need to understand what is interlock. So that's why we showed you the video first for you to have a basic what I call it, imaginations where which kind of places that we're going to implement it. So let us explain to you the meaning of interlocking. Okay, so we'll just look into this part here. Sorry about that. Okay, what is door interlock system? From the video we can understand it is a security mechanism that prevents access through a door until a certain condition is met. The system locks the door until the condition is fulfilled, and it ensures that multiple doors cannot be opened at the same time, providing added security and safety. Usually, these are used in clean rooms, cargo, changing rooms, crowd control, linen chutes or dirty laundry chute, rubbish chute, prison cells, zoo animal cage, and etc. These are the few examples that I can give, but there are many use cases along with it as well. Two-door interlock pass-through. Today's functions, the first functions we will be discussing on this matter is the two-door interlock pass-through. There is no such thing as one-door interlock pass-through, okay? Because for interlock to happen, you need to have more than one door. That is, minimum of two doors is to be there for the interlock to work or the system to be applicable. One door is already access control, guys. So from two door, you can have 3, 4, 5, 6, and as many you as you want. Okay, but the most basic as minimum easily can be explained is using two doors. So in this example, these illustrations, we have two different doors, and one is at the left and one is at the right. So we are simulating as if it's a room where they have two, front door and the back door. Okay, so right now the condition has been set as any side of the door can be used. That means a person can come from the left, from the front, and or maybe from the back. Okay, they can come through either way. Any doors they can be used. Okay, so it's currently in the ideal condition, the both doors is able to be accessed. Let's say for this example, a person comes to the front door and opens the door. The moment the person opens the front door, as you can see that the back door cannot be used. So the back door has been in lock condition right now. So no one will be able to come through the back door, okay, until the front door is closed. So once the person goes in and close the door, and the back door is able to be used, okay, and as you can see that the front door is still in the lock condition. So there is a buffer state where the front door will be kept as closed. So no one will be able to use the front door until the buffer time ends. So that means even the person from inside tries to go back, it will not be able to go back. Okay? The only way the person can do is pass through the back door. So once the person passes through the back door, then it's called a successful pass through. All right. So after the back door is closed, the system becomes back to normal. So this is not only applies from the front door to the back door, it is also the system works as from the back door to the front door. So either way, the person is able to do an interlock pass through from either direction as well. So, sorry, I was muted. So we did see the first basic interlocking system. Okay. So what we are saying is in two-door interlock is the most basic. Okay. By knowing the two-door itself, now you are able to even know what is how it would be for more than two doors, 3 doors or 4 doors or 5 doors. Interlocking means is locking the condition itself. With that being said itself, okay, is there anyone else has any questions before I go further? Because after we are going to enter into a technical, a bit more technical to understand further on how the functionality works. The initial one was to introduce to you what is the locking system works. Okay, so if there's any questions you can ask now, else I will continue with a video slide as well. Okay, so in that cases, I'll continue. So with that, our previous examples, our basic interlocking system has been explained. Okay, so that was the gist of it. Anything to do with interlock is got to do with that. Is one door opens, all the other doors close, and simple as that. Now let's go into technical details in each every one of the process. Okay, to look into what else functions that this board can offer. Okay, in compared to the normal interlocking systems, what this interlocking board can offer. So let's start with our two-door interlock explanation. Before we go into it, okay, we have something known as what I call door closed. Okay, where the door sensor detects doors closed, we have this sign here say closed. When the door is open, the door sensor says that it's open. Okay, and we added another one more called unlocked state, where the EM lock is unlocked. Okay, and lock state, where the EM lock is in lock condition. So as you can see that normally all the doors are closed, but you will have a EM lock there which is locking the door itself. So in our cases, we are using a lock here, which indicates as the EM lock. And this green light and red light indicates as the indicator, where we can the door is in idle and usable condition, or is the door is in what I call the unusable condition. So we say that cannot be used. Okay, so this is our jargon words that we will be using in our next slides, so that it will be easier for us to explain the process of the interlocking is taking place. So two-door interlock side, where the both doors are in closed time, okay, and the EM lock is in the lock condition, and we have a push button here which indicates as those are the ones where we're going to use to open the door. Okay. So when the person presses the push button, okay, as you can see, the first door, the EM locks unlocks. Okay, so this door is able to be used. But the moment the EM locks unlocks, the second door becomes lock condition. As you can see, the red light here indicates that it says that this door cannot be used. Okay, so the EM lock remains locked and the push button becomes unable to be used. So the moment the person opens the first door, the other side remains, okay, remains locked. So even the person tries to press the push button to open the second door, the door will be still remains locked. So this is how a system works, okay, with the push button and door opening conditions. So the IO board has an additional feature where our fifth relay will be used as the indicator relay. So it's able to indicate whether the door can be used or cannot be used. So that will indicate whether the light is green or red. At the same time, it also will be indicate another condition called the fault state condition. which is not supposed to happen, but just in case, if we do so, we have an indication for that purpose as well. So the fifth relay can show the active state. So in that cases, in the fifth relay will be a green light, okay, showing there as the both doors are in idle condition. Okay, the moment one of the doors is open or the push button has been pressed, the light changes to red. That is called the inactive state. For some reason which not supposed to happen, if the both doors is open, then it becomes in the false state where the green and red light will be switching with pulse, green, red, green, red, green, red. So they'll be pulsing one after one. This will indicate for us that something has gone wrong. Okay? So this is not supposed to happen, but just in case, if it does, we have a warning sign. With two-door interlock function, we... Alright guys, so we covered a two-door interlocking system. Okay? So two-door is where, yeah, how to say that, they are basically easy to understand. So as long as we have that understood means, then we're going to the four doors, it will be not confusing. So because more we know that doors are not, is huge. We cannot show it in the video how it's taking place. Okay, so it's not very easily to notice. We just need to use our imagination to imagine the condition itself. Okay. So is there any questions before I go into the four-door interlocking system? Okay. Okay, so if not means you can while the I'm playing the presentations, if there's any questions, so you all can put it in the chat group then we will look into it. Okay, let me start back. With two-door interlock function, we already have a better understanding of how an interlock works. So let's see how we can achieve four-door interlock system. As you can see, since the I/O board have 4 inputs, by making all the inputs as door sensors, we are able to make it into a four-door interlock. First, let's look into a normally open condition of the four-door interlock. Normally open condition, all the doors are initially unlocked. There is no need for push button or access control for the system. As I mentioned earlier, normally open condition means all the doors EM are unlocked condition, where you can open any door straight. At any moment you open any one door, all the other doors EM will be locked and will not allow anyone to use the door. Four-door normally open interlock system is our most commonly used interlock. It is very simple to configure, where all the doors are unlocked condition. Moment any one door is open, the rest of it will be locked. So let's move on to our next interlock system. Our next function is four-door interlock, but normally closed condition, where all the doors EM lock are in lock condition. Okay? The EM lock are all locked. So you may ask, I/O board only have 4 inputs, okay, which is now right now is used as door sensors. So how do we unlock the door? So the way we can unlock the door is where we will be using, okay, where we will be using our wireless reader or wireless RF. Okay, they will be able to trigger the door to be unlocked. Okay, so this is a 2-part incident where we use I/O board plus a wireless system. As I mentioned, normally closed is where all the doors are in lock condition. For this example, let's use a wireless reader to interact with the door. So When a valid signal is sent, the door will be unlocked. So now the corresponding door can be opened. Smart I/O board accepts the RF as remote to open the door. We can get off the shelf 433 MHz RF remotes. And here are some examples of the remotes. Using microID's wireless smart converter, you can use the I/O board as an access control with interlock function. Smart converter can support up to 2500 users. And this wireless is more secure with AES 128 encryption than the 433 RF remote. Well, in 4-door interlock, also we have fifth relay as the light indication, where it have active state, inactive state, false state. False state is when two or more doors are open. Okay guys, we have come to our final function for the interlock system, multi-door interlock. But let's first watch the following video. Let's see what is linen chute or rubbish chute all about. In tall buildings such as hotels, condos, apartments, they have a location where they can throw rubbish or dirty clothes. These are called chutes. So interlock can be used to make sure one chute is open at a time. So falling objects from above floor will not injure the person opening the chutes on the lower floor. Since there are more than 4 floors in a tall building, we use multi-door interlock to lock all the chutes door. You add multiple I/O boards that can communicate with each other to make it a multi-door locking system. Multi-doors are used when more interlock doors are needed than the board itself can support. So we use multiple boards where they can communicate with each other to achieve this scenario. Interlock Gen 2. The demand for interlock. All right, guys. So this is the most of the complex interlocking system. Actually, interlock is very straightforward. So that's why we don't need to talk about it too much. Okay. So we are nearly coming to our end of the session. Okay. There's another one more, which I'll talk about the interlock generation 2 series. So far what we have covered today was the 2-door interlock and the 4-door interlock. Okay. And the concept of how to make use of it itself. And how we can achieve a locking system from one door to another door. On the market until now, what you have is, let me stop the slide, show. Okay, so on the market, normally that you have interlocking system, which is already, you can say that in the market, you already have interlock system. But most of them are used by relay controls or just a basic relay. When you trigger open one door, the other door locks, and the moment you close it, the other door releases. Okay. The condition that you can't apply is buffer times or what do you call that? Maybe a delay time, or maybe that board itself is an like a momentary open or momentary close conditions itself. So in using the board that we have, like our I/O board, you are able to achieve certain logics along with it itself. Okay, so it's not just the 2-door itself and 4-door. You are able to even go to a multiple stage of doors as well, and add in the buffer time, when to control, when to release, those kind of things. So when we So we used to sell a lot on interlocking system with the IO board, especially the chute controls, the rubbish chute, where we have multiple levels, where they wanted to make sure that seal of each level when they open up. Okay, and few places in clean rooms, they end up using multiple loop system for adding a master control. So once they enter the room, they create a master and locks the system. Because we're using board and not just relays, so the board for the logic, the wiring and maintenance of the things was much more clean. Okay, so it's not like as if you need to worry about what is the relay, which relay does what, or you are able to program it. When something happens, all you have to do is replace the board itself and add the configurations. So the wiring, and things are, it's very clean. Okay, that is one of the advantages we had. So while working with this IO board, there was many things we noticed. Users keep on asking of improvements on the interlocks and logic states and more conditions. So because of that, we had to come up with the ideas to generate something new. Okay, so it was long last and all those kind of things, and finally we also released one because there was a demand for it was coming in. So we created another one more as an introduction as Gen 2 Interlock Gen 2 as well, which can do more many things than the IO bot can do. So if anyone have any questions can ask, or else I will start with the Gen 2 explanation. Okay. Yeah, let me share screen. Okay. So Interlock Gen 2. The demand for Interlock was a lot. So we built a new Interlock board that can do many extra logics as well. And the board is also customizable to any scenario that is needed. This unique board overcame most of all the limitations the IO board have. By increasing the inputs to 10 and having 2 dedicated loops for multi-door communication, the board has evolved from the simple IO board. So therefore we named it as Interlock Gen 2. The 10 inputs has been divided as 4 dedicated input trigger for push button inputs or access control inputs, and 4 dedicated door sensors for the door sensor inputs, and 2 dedicated master inputs, which can be configured as either master release or master lock, and 4 relay outputs for the doors, and 1 relay for indication or alarm. The indication is for the light indication. So the multi-doors is the same concept of the IOBots multi-door communication. Okay? So in this chart here on the left, as you can see that how the matrix configuration can be configured. It's so versatile that you can choose how the interlocking works. Sorry, I was muted. So basically the Gen 2 has created more conditions itself. The unique part of the system also made us in a way that you are able to customize for your own need. So that means the basis on your projects where you have conditions of the interlock is a bit different, we are able to customize it accordingly. Of course, the basic condition is there for you to immediately we can do the configurations, okay, and the logics. That's why there is something called the matrix configuration style. Let me see whether I can enlarge that particular slide for the matrix one to explain a bit more. Right, I think that should be. So share screen. Okay, so I think I'll put the font a bit more bigger. Okay, so you can see that we are able to configure. This is a gist of it. There's actually more logics can be added to it, but the core logic is this part. Okay, where you can say that if door one, sensor one triggers means which are the door you want to make sure that they are locked. Okay, you can even make it in a way that saying that if door one and door two is the same room, the interlocking should happen when the door two is open. I still can open door one. Okay, but door three and four will be locked. So the logic is endless. Okay, this is something that the IO board initially cannot do. IO board is condition is everything. One door opens, all the things locks. There's no such thing that you can have a versatile condition as well. Here, you can create an independent condition or dependent condition as well. And master also the same. You can tell master release or master lock. You can actually select which one. Let's say fire. When you're going to have fire input, and then you can say the master release. So you can set up a master one as fire release, and you can set it up which door should release when the fire happens. Okay. Master lock is locking condition. You can even define which are the doors you want to make sure they're locked. So in this case, in changing room, you can have a locking system. The moment it goes there, there's a lock it, and you can say that which doors should be locked. Okay. And for this loop one, loop two is got to do with the, what do you call that? Multiple doors. That means you can see one board only can control 4 doors, but by having multiple boards added to it, you can control more. Okay. Not only that, you can even say that in one room, okay, in one room, the door 4, yeah, I should have added that one of the maps. Okay, it would have been nicer to show the loop maps itself, but yeah, that one I'm not sure whether without, yeah, maybe in the future I'll try to add it into the video, the loop map itself to explain that one much more better. So you can actually say that loop door 4 is the one when shared by multiple loops. Then you can define it, say that when the door 4 opens, all the other loops should be locked. Okay. So this is a bit technical, but if you all worked on interlocking or clean room, if you might have, you get the idea of what is being saying here. But even initially, when we were working on it itself in the interlocking, we had a lot of trouble to understand. So while working with the customers and knowing the scenarios and places, we learned quite a number of it. So that's the conditions of that is our end of the slides of the interlocking. And let me show you the hardware specifications. So at least we get some ideas on the specification side. And should I share full screen? Here, give me a moment. I think I just share it like this. Share. Okay, so Gen 2 specifications, the dimension, Gen 2 is bit 2 times bigger than the, I think 2 or 3, 2 times bigger than the IO board itself. Okay, so you can see that its dimension is, it comes with the DIN rail enclosure. Okay, Gen 2 comes with like a DIN rail enclosure condition as well. Okay, so it has a dimension of 120 to 200 mm. Okay, the current consumption is around 50 to 70 milliampere, which is it. When you're using all the, if let's say all the relays are triggered, you'll be using around 325 milliampere. Okay, so you just can plus, you need to plus that one with the base to get the full ampere. So this is the Gen 2 thing. And IOBot is, I can say the dimension is 57 and 93. Yeah, it's really, I can see that it's double the size of the, I mean, 2 times smaller than that previous bot. Okay. It's capable of accepting Wi-Fi, Bluetooth, and a few other signals, wireless signals itself. Okay, so our interlocking conditions in future, we will be having, let's say in today's example, we showed you that you can open the interlock by RF switch and by micro ID's wireless reader. Okay, we in the midst of, currently we have Android based Bluetooth. So if iOS we added ready, then we will publish the entire Bluetooth condition itself. So you can actually trigger to open the doors by Bluetooth as well using the app. So that will be later, we will try to implement that. So I just want to tell you about that. So with that, we end today's interlocking system. Okay, so yeah, thank you. If anyone have any doubts. Okay, so previously, I think we covered on the process of the wireless. Okay, so intermeets, in future we will be developing boards where the wireless readers and wireless condition will be, they are able to, it's like a jigsaw puzzle. We'll try to make it in a way that they can work one another itself. So stay tuned for that. I'm not sure what will be the next. Yeah. With that being said, thank you guys. Thank you for coming today. Stop.